project is design of step-down DC to DC converter for next generation microprocessor. First of all, I would like to thank the Texas Instruments Innovation Challenge Committee for giving this nice opportunity. Our team members are A. Arun Kumar, S. Balaji, B. Deepan, and myself, S. Mohammed Yunus. We are under the guide of Mr. S. Ravi Varman, UK's Rangaswamy College of Technology. First of all, I will explain the block diagram. Our block diagram is first of all in AC supply 230 volt. We give the AC supply of SMPS. Then the output of the SMPS is 12 volt. In this SMPS to motherboard we give to about 5 volt or 12 volt depend upon the company. In this 5 volt we base the voltage. We decrease the life of the adapter and switching losses. There is a switching losses, high body diode loss and conduction loss, like this lot of losses in this transistor switches. So thus we use a DC to DC converter. We give the required input voltage to the processor. Here this is the overall block diagram. This is the circuit diagram. Here the first diagram shows a two-phase circuit diagram. The second diagram shows the four-phase circuit diagram. In each phase we use 2 MOSFET. The 4-phase means 8 MOSFET. 360 divided by n means number of MOSFET we used. First 2 MOSFET means synchronous buck converter. Each MOSFET operated in a synchronously. And second MOSFET is in each phase. First MOSFET is operated input supply. Second MOSFET is supplies charging and discharging of the capacitor. In inductor we use the inductor to reduce the harmonics and ripples of the output voltage, because DC is a step output is so that the here harmonics. So the here we simulate the single phase basic diagram. In single phase basic diagram there are 2 MOSFET we used. Here inductor, capacitor and voltage. I simulate. First of all, this MOSFET is operated in a input supply. Then this is a closed path to operate this MOSFET. I will run the circuit diagram. This is our output voltage. Here this is the first input voltage gate pulse. This is the second input voltage gate pulse. This is the output. First the straight line input voltage, because on off condition in duty cycle. Till now we see the simulation of the circuit diagram for single phase. Now we see the hardware of our Texas Instrument kit. Here we use the SMPS. We give the input voltage of 12 volt. The SMPS buck the input voltage of 230 volt to give the output of 12 volt or 19 volt depend upon the company. Here we give the input of 12 volt for the converter. These are the two converter. Mainly we use the buck the DC voltage. In this DC voltage, this is the in this stage, each stage has a 2 phase. This is first stage, this is second stage. There is a 4 phase. 4 phase means 8 MOSFET. 8 MOSFET, the duty cycle 360 divided by n. Number of MOSFET what we used. Here this is the input, this is the output. Here this is input, this is output. MOSFET is a voltage controller device. In this MOSFET, buck the input voltage 12 volt to 2 volt or 1 volt. Buck the input voltage and increase the current. This is a ferrite inductor material. This ferrite inductor operated a high frequency and high current. In DC there is a harmonics, ripples and noisy condition. We eliminate this so that we use the capacitors. In these capacitors eliminate the harmonics. These diodes is that there is 2 purpose. One is a blocking the reverse bias and reduce the ripples and reduce the harmonics. These are the main, and also reduce the conduction losses and switching losses. Here we consolidate this output and take the output in this terminal. In this we consolidate it, means there is a harmonics and noisy. We eliminate it so that we use these 4 capacitors. Here we use relay for the protection of MOSFET, which is a high component, so that we protection of MOSFET. This is the why we go to the DC to DC converter, means in previous generation microprocessor like Pentium 3, Pentium 4, i3, i5, i7, it requires only 1.5 to 1.7 volt, but we give the input of 5 volt. What is the necessary? There is a damage of transistors and life of adapter, and decrease the life of adapter and high switching loss. There is a hanging of a system, like that lot of disadvantages are there. So that we use this converter and reduce the reduce the power consumption and reduce the voltage and increase the processing speed of the processor. This is our main objective of the kit. Here I on the kit. This is the SMPS, this is the 2 converter, this is the output voltage relay. We give the input of the processor in these 2 terminals. In future we reduce this output in 1 to 2 volt. Let us see the kit in closer way. Once again I would like to thank Texas Instruments Innovation Challenge Committee and Managing Director and Chief Executive Officer to giving this nice opportunity with my guide and my department and my friends to helping me. Once again I thank you to my friends and non-teaching staff and teaching staff, and thank you.